Good morning, everyone. Welcome to the week 3 computer practical. I particularly hope that those of you who haven't used MATLAB before are getting on well with the practicals. Please do email me if you've got any questions at all. Okay, I'm excited about this week, and again it ties in exactly with the material. So in the first week we looked at kind of Hurricane Sandy and just getting you started on sort of processing sea level data. And then in week 2 we exactly mirrored the lectures. We started to look at mean sea level and we used data from the Permanent Service for mean sea level. This week we are going to look at predicting and analysing and predicting tides using the harmonic analysis method. And we're going to step it up a bit this week. In the first 2 weeks, we just used data from one site. Now we're going to use data from 5 sites in China and Vietnam. But to keep things simple to start with, let's just start with one site. And we are going to look at data from the University of Hawaii Sea Level Center. Now, for a harmonic analysis, you normally need high frequency data. So we're going to use hourly sea level data, and we're going to separate out the tidal component and look at various harmonics and predict the tide into the future. And we'll look at the form and the range of the tide, calculating that using the main constituents. So let's get started. So as always, navigate to your folder. So here you can see I'm already in my SOES6011 practical folder. Let's go into Practical3. We're going to start a new script. And again, I'm going to keep it simple rather than giving these complicated names. I'm just going to call them Control1. And we might as well jump straight to it, actually. But this week, we can create a README file as well that we can add to later. Okay, as always, I put my, sorry for my calendar coming up. As always, I put my name, the date, and then a description of what this M file does. This M file does a tidal analysis and prediction for one site. I'm going to clear the variables and clear the screen. And then the first thing I'm going to do is I'm going to load in the data. Okay, now I'm going to go to my Safari. You can go to your Explorer and type in Hawaii Sea Level Center. And it's the University of Hawaii Sea Level Center. And we can click here. This is actually run by a friend of mine, Philip Thompson, out of the University of Hawaii. You can click on Data, and I'm going to use the legacy data portal. This is a slightly older one, but I know it well. And we'll click on Research Quality up the top here. And what I'm going to do is I'm going to sort by location until we get to the X. And the first site we're going to load in is this site from China, sites 376 from China here. And we're going to go along and we're going to go look at this netcdf format, and we're going to do the hourly. And that should have downloaded now. So let's go down into my download folder. Let's open the Practical3 folder. Let's create a new folder called Data. While I'm here, I'm going to create a folder called Figs. I'm also going to create a folder called Mat Files. So now let's go into my downloads, and here you can see a netcdf format. It says h376a.netcdf, and actually I'm just going to copy and paste that file name later. Now, netcdf has increasingly been common in more recent years, and it's particularly useful for kind of big data sets, gridded data sets. Now, on a standard PC, you won't be able to open this. You can't open this in a text file, but you can download specific netcdf format openers if you want, but I find it easier to do everything in MATLAB. Okay, now to make things simpler as well, we're going to say file in. Remember, this is a name, so it always should be in quotes, put the semicolon on the end. Now the folder is data. Okay, now we could do this, but again, I'm gonna I want this to be able to open for any site. So the only thing that's going to change is the number here. So I'm actually going to take the number out. So I'm going to join the first bit of string to that number to the next bit of string. So let's take this number out, and I'm going to call it site ID, a bit similar to what we did in the second practical. And then here I'm going to do SID. We can turn off the semicolon and run that, and hopefully we can see it's generated the file name. So if I change this, if I download some new data, and then I'm going to use a function called nc, so it's a netcdf, nc display, and we just give it the file in, and we can run that. And this loads to screen everything that's in the variable. So it tells you the title of the variable, when it was created, who the publishers were. Here you can see Phil Thompson's email address and various details about what's in there. So there's a time matrix, but the key thing we want is variable here. So there's this matrix called sea level, this matrix called time, lat, long of the site, the station name, the country code, and various other things here as well. So let's first of all load in time, and I do quite like to use commas just to remind myself what I'm doing. So I'm going to say TS is the time string. Now to load in a variable, you use the function ncread. You need to tell it what the file in is, so this is file in, and then you need to have the variable name. So we can go back and check, but the variable name here is time. Okay, and I'll put a semicolon on the end there. Okay, so if I run this now, I'm actually going to switch off this net. Well, actually, I'll leave it on for the time being. I'll switch it off later. Okay, so you can see it's loaded in this time data set, and we can double click on it and you can see it there. But let's go back to the information here. It says time is the days since 1800. So really, MATLAB, all the days are from kind of the beginning of sort of AD time. So we just need to correct that. So always have a look at the time, because it won't necessarily be in the correct MATLAB format. So I'm just going to overwrite TS. I'm going to say TS is equal to TS plus, in fact, you can tell this because if we go back here and type the keywords date string, TS, and just the first variable, it will give us a really odd date, which we know isn't right. So here I'm going to use the date num function, and I'm going to say I'm going to add 1800, because MATLAB is the number of days since Jesus was born, essentially 000. And we can check that date string TS1, so let's run that again. And you can see now it's the 1st of January 1954. And I think we can come back here and check it. 1st of January 1954. We can even check the last one if we wanted. Copy that again and put end. And you can see it's 37th of December. Let's go back here and it's the December 1997. Yep, brilliant. Okay, so we know that's working well, so I can take that out. Now for plotting purposes later, I'm going to create a TS2 and I'm going to convert this into a date time. So it's TS, and then you can use convert from date num. This date time thing is new in MATLAB. It's just a much easier way to handle to time. Whereas this TS is the number of days. This one is a proper kind of date time matrix, and you can double click on that and see now. Yes, this original TS is a bit hard to read because it's the number of days since Jesus was born, whereas this here is a proper time. Okay, so the next thing we're going to do is load in the water level. Okay, so here I'm going to have a variable called water level. Again, I'm going to do ncread. I'm going to have the file in, and now the variable name. And the variable name in this instant is sea level. So we can copy that over. Sea level. Okay, now let's load this in. Now here you can see there is a matrix here now called water level. So this, we don't know what the units are yet, so let's check here. Go back to sea level. The units are in millimeters. So let's say it's water level equals water level dot divided by 1,000. And we'll put a comment there just to remind us later, but convert to meters. Okay, that's good. Now we can load in the station name. So we're going to do n, and now we can do nc read the file in, and again you can have a look down here. I'm pretty sure there's something called station name. I'll leave the semicolon off for the time being just so we can read that. Oh, it should be file in. And you can see it's done the name there. Okay, now it's done the name as a column vector, so I'm going to put a prime at the end and run that again. And there you can see the name is here. There's the name. Okay, just to be, yep, that's the name there. Okay, so the name is I won't even give up. I'll give up. I don't even know how to pronounce that. Okay, now we're going to load in lat and long. And again, I'm just going to copy and paste this because it's easier. So I'm going to put this as lat and this as lat. And then I'm going to put long and this as long. I'm going to run that. And there you can see we have the lat and long. We can check that. We can go back here and just check it. 24.45, 18.06, 24.45, 18.06. So it's loaded that in correctly. Okay, our next step is to plot the data. Okay, let's bring up a new figure. And like before, I'm going to put the units as normalized so that my screen goes from kind of 0, 0. I'm going to set the position and I'm going to do 0.1, 0.1, 0.8, 0.8. I'm going to do A1 is a subplot, and now I'm going to plot the same data 3 times, but plot zoom in on different parts of the tide. So here I'm going to use TS2 because that's a slightly better time matrix. I'm going to plot it as blue, and I'm going to make the line width 2. Now let's just jump straight in and do everything else. Let's set up the X label while we're here, level meter. I'm not going to, sorry, the Y label. I'm not going to set up the A level yet because I'll do that at the end just for the final one. We don't need 3 years. We can just have it all 3 dates. Going to do a font size 18. So there's lots of extra properties with things that you can set it up. I'm going to set the axis itself as font weight bold to make it look better, and font size 16. I always do these little things right from the beginning because they make the plot looks much nicer than just the kind of standard MATLAB settings that are quite small. So I'm going to put a box on, I'm going to put a grid on, and I'm going to put a title. We'll come back and do the title in a minute, but let's put the font weight bold, font size 20. And when I'm doing any report or paper, I try and always have my title as 12, my font as 16, my labels as 18, then it's consistent. Now here with the title, I'm going to put the name of the file, but actually I'm going to be clever here and vary it. So I'm going to put square brackets to add text together. So I'm going to have the site and then the number, which is SID ID, which is defined up the top here. And then I'm going to have a comma and a space and then the name of the file. So let's run that. Okay, there you can see it's plotted nice at the top. So here is our data. So we have 50, 60, 70, 80, so almost, well, more than 40 years of data. And it looks pretty good. Now what I'm going to do next is I'm just going to copy this line again. And we're going to produce a second subplot here. 2. Except here, I'm just going to, let's change that to A2, this to A2. Now here, I'm just going to add another line where we set A2, set the axis, and we're going to set the X lim. So here we're going to vary the X limit. And you need two numbers, and they're going to have to be date time. So now I'm just going to plot 1996, 1, 1. So you start with a year, day, month, hour, minute, second, and now I'm going to plot a year. So rather than over 40 years, I just want to zoom in. It's exactly the same data, but I just want to zoom in and look at 1 year. We don't need the title anymore. We just need that for the top one. Okay, let me just check that I've done that correctly. No, I haven't. It should be A2. So now you can see we've zoomed in a year, and now hopefully you can see the features that we saw in the lectures. A spring and neap tide. One spring is always bigger than the other because of the perigene-apogene cycle, and then we kind of have our largest tides at a certain time of the year. Although at the moment this is total water level, so that peak there is probably a cyclone. Okay, we can now zoom in and set A3. This will be 3. Set A3, A3, and this time I'm just going to zoom into 1 month. Let's zoom into July. So we're going to go from the 7th to the 8th and run that. Okay, that still hasn't worked because let's see what I've done wrong. Date time, so let's zoom it again. Oh, I haven't changed the year here. Sorry, this should be 1996. Okay, and there we have a month, and you can see the spring neap tidal cycle. We have 2 tides a day, so this site is semi-diurnal. Okay, let's close it. Now I'm just going to add one more thing. There's a nice function called switch, and I'm going to have a fig. And up the top here, I'm going to define fig, and I'm going to have y or n. Y is yes. So what I'm going to do is switch fig case y, and this is a little bit like an if loop. It's just a nice way, and really we should go up and indent the code. So what this is going to do is, it's very simple, but if this fig is y, you'll see it will run through and plot the figure. If this fig is no, it's not going to plot the figure, because later on I'm going to turn this script into a function, and you can see no matter how much I run it, it's not going to plot it because I've got it as no. Okay, so that's loading in the data and plotting it, and then next time we're going to get a bit more exciting and do a tidal analysis.